Hi guys, how are you? How doing? We're back to you again with the fourth review of mathematical inductions. Uh, Today it will be a new proof, a little hard, not that much, but a new nice and interesting concept. Very nice and interesting concept. Okay, let us talk about, see what this concept, but don't forget at any time you can contact me, send a message, email me if you have any problem. And our topic is still mathematical induction, and this is the fourth review. Let us back. Okay. I left something here, space for me to start something new. We'll talk about something we call it geometric sequence. Geometric series. I'm going to start with what? I'm going to explain the concept of geometric first. What I mean by geometric? Why is geometric like this Slavic, right? Geometric series. Geometry. Let us discuss this concept first. The geometric series is a series with infinite terms. Her terms goes to infinity. There is something special in geometric sequence. There's something special in geometric sequence. What's that special thing in geometric sequence? The special thing in geometric sequence is the ratio. If you divide any two consecutive term in this geometric series, you will get the same answer. What I mean by this? Look to this example. Example 1. 2 plus 4 plus series 6. I have to add plus. If you said sequences, you will deal with sequences. Sequences mean commas, but we deal with series. Plus 10. No, that's wrong, right? 4, 8. Okay. That becomes arithmetic, which is the new class. 8, 16, 32. Okay, let us see what the ratio between 4 divided by 2 is 2. 8 divided by 4 is 2. 32, you see, look here, we go up, let me get my arrow. 32 divided by 16 is 2. When we have the same ratio, we call this what? Geometric sequence. The number here, 2. We call this R. R is equal to. We call this term 2 first term. Or we call it A1, or we call it what? We call it A1. We call it A1. We call 4 A2, the second term. Four is A2, the second term. Now we keep going till we reach the last term we don't know, which is AN. an could be a1 or 2 or 3, right? You see that? Subscript and a1. I need to find a formula for an. Formula for an if I know a1 and r. a1 and r. What's this formula? a1 and ar, right? Then my objective is to find the formula for this and make it easy for me if I know L1 and R. This formula, an equal a1 R. I'm going to make a1 in the okay, n minus 1. N minus 1. Okay. This is my formula. This formula, the formula to help me finding any term in the geometric series. Then this formula help me to find any term in the geometric series. If it's, look here, if you're looking for this 1, 2, 3, 4, again 1, 2, 3, 4, a4 equal, we're looking for a4. a1 is what? 2, right? And right? a1 is 2, r is 2, we found it. 4 minus 1, 2 times 3, 2 times 8, 16. 1, 2, 3, 4, 16. Then this is the formula. Okay. Now, one more example. Look to this formula. Another example, make the question example. Okay. 3, 1, 1/3, 1, 9, 127 to the AL. Let us see. Let us see. This is okay. From here to here. 1 divided by 3 is 1/3. From here to here. 1/3 divided by 1, look here. 1 over 3 is 1/3. 1/3 over 1, you can see here. Let me just raise it and write. Maybe you cannot see here. Let me just okay. Let me write it here. You see the first two terms here. 1 on this side. 1 over 3. The first divided by what? This divided by that. Okay. 1/3. And 1/3 divided by 1. 1/3 divided by 1 is 1/3. 1/9. 1/9 divided by 1/3. Everyone knows keep change flip. 1/9 times 3 over 1, 1/3. Okay, then everything give me what? 1/3. Then I know what's my A1. A1 3. R is 1/3. Now in this case, look, sometimes my R is a fraction less than 1, and in the previous example my R was a number greater than 1. Okay. Now I can write my AN formula. AN equal A1 R n minus 1. Good. A1 is 3. R is 1/3. n minus 1. Good. Now, let us finish this problem and see if we can find this 1, 2, 3, 4, 5. Let us see if that's true. A fifth, 3, 1/3, 5 minus 1 is 4, and 3, 1/3 to the 4th, 1 over, how many threes? 1, 3, 2, 4 threes, right? And if you cancel the 3 with the 3, this guy with this guy, we'll have 1 over 27. Why? 3 times 3, 9 times 3, 27, which is that term. Now, I think I have some minutes to keep going. Now, the question always, to find the sum and to prove it, we use mathematical induction. I will not prove it today. Today is introduction about geometry sequence. But I need you to understand the geometry sequence. Now, what we notice from these two problems, we notice there's 1 times r greater than 1 or r less than 1. Yani, this is the number line. My r, this is -1. My r, we don't use 1. My r could be to the right of 1 or to the left of -1. And the second type of geometric sequence, when r between -1 and 1. When r between -1 and 1. You see, I have two types of geometric sequence. The first type has a ratio, and the ratio goes from 1 to the right or from -1 to the left. The other one is between -1 and 1, like the one I did, which is 1/3. Right? And here I get an example. My objective is to find the sum of n terms. Sum of n terms, that means sum of n terms of this one, a1, the first term, 1 minus r, to how many terms I need? And you know what r is the ratio? Over 1 minus r. Then, in this case, to find the sum of n terms, you have to know how many terms you need to find the sum, and you have to know the ratio, and you have to know the first term. This guy is easier. Now in this case, it's a beautiful case. Sn equal only a1 over 1 minus r. This is the sum. Look here. Here in this case, when r is between -1 and 1, you can find the sum of the whole geometric sequence right away. You can find it by finding the first term over 1 minus r. Example, my example here, my previous example, you remember that one? The one I did just recently, which is, why here, okay. Oh, the one before, 1, you remember that? 1, 1/3, 1/9, that one. This is had this case. This belongs to r equal 1/3, right? r 1/3 is here. What's the sum of this? What's the sum of this guy? The sum is n. A1 is what? 1 minus 1/3. Easy. This from here till infinity. from 1/3. From 1/3, 19, 127, 181, 1243. Keep going. Well, look here. The numbers have to be smaller. 1/3, 9, 127, 181. You can add plus. 81, 1243. All the way. You see the numbers become very small. 1/243. If you add all this guy, 1 minus 1/3, 2/3, 3. Keep changing from 3/2, 1.5. Then the sum of all this from 1 all the way, it's about 1.5, which is make the thing easy. I'm gonna leave this guy for next time for when r is greater than 1. Guys, have a nice day, and thanks for listening.